All right, so for example 3, it asks, show that x grows at the same rate as x sine x as x goes to infinity. So I'm going to set up that limit as x goes to infinity of the ratio of those functions. And my issue here is this I can't actually evaluate, right? We know this oscillates going between 1 and -1, but I can't answer what happens as x goes to infinity. And so this is kind of like, I feel a little bit stuck. If that is the case, one option for you to try in terms of being clever, maybe you could think about it like that. What happens if I write the other function on the top instead? Okay, I still have that same issue with evaluation, but I do have the ability to do a little bit of algebraic manipulation here, okay, and call this 1 plus sine x over x. And if you recall back in the day, okay, we talked about this being one of our special limits that we would just know. And so this is 1 plus 0, which is 1. Since this is a non-zero constant, both x and x plus sine x grow at the same rate. Okay. Likewise, in example 4, okay, the problem here now is let a and b be numbers greater than 1, show that log base a of x and log base b of x grow at the same rate as x goes to infinity. So I'm going to do the limit as x goes to infinity of log base a of x over log base b of x. As x goes to infinity, we do know how this acts, right? Logarithmic growth is slow, but it is growth. So in the long run, this is an infinity over infinity situation, and so it is L'Hopital eligible. However, L'Hopital is only helpful if you actually know how to take the derivative. Okay, and so you need to remember what is the derivative rule for log base a of x. All right, so this is a good reminder of some of those rules. It is 1 over natural log a times x. And on the bottom here, derivative of log base b would be 1 over natural log of b times x. Okay. Certainly this is a great opportunity to practice our rewriting before I try to evaluate. And so I'm going to have 1 over natural log a, that quantity, times x, times, instead of dividing by this fraction, I'm going to multiply by its reciprocal. Okay, so natural log b times x over 1. Which means this is really the same thing as the limit as x goes to infinity of natural log b over natural log a, right? And if you take the limit of a constant, it is just that constant. And so both of these would represent just numbers, okay? This is a non-zero constant. So my conclusion would be that log base a of x and log base b of x grow at the same rate.